in C. What is the linked list? That is the dynamic memory allocation memory allocation. The memory is already fixed. We cannot change at the runtime. Whenever we need at the runtime some memory, that is not possible. Linked list is dynamic memory allocation is done by using linked list. There are three types of linked lists are there. One is single linked list, another is double linked list, another circular linked list. Coming for the single linked list, for a linked list, there are minimum two parts will be available. One is called the data part or item part, another is called the link part. Data part will contain some datas. That data part must be minimum one data part should be there. That means there may be more than one data part available. And also there must be a link part that will link the next node. If you want to define a node of a linked list means actually the collection of some nodes. Node that will hold some data, and that node will also contain the address of the next node. Here you can see here that for a particular node, minimum one data part is available. Another is called the next part. That is the next is the link part that will hold the address of the one data type, may be integer type or float type or character type. That is the data part. Another part is called the link part that will hold the address. That must be a pointer. So two different data type we have to store. For this reason, we have to use structure here. For the structure, we are defining here struct node. One data part lets the data part is integer type. So we are declare here int data. Another part that will hold the address of whom? Hold the address of next node. Node is defined by some structure. So here we are using struct node pointer. That means that will hold, as you already know, pointer p means that p will hold the address of whom, which type of data type we have declared. Here also we have declared here struct node pointer. That means that next pointer will hold the address of another node. So here is the definition. Now coming for that, here single linked list. Single linked list means there's only one link part will be available that will hold the address of another node. The last node address will hold null. Here the last node element has a link value with null. You can see here in the picture. Now for a double linked list, in the case of double linked list, there must be minimum two data type available. That will hold the address of the first node and address of the next node. Alright, here two link part is available, the previous link and the next link. The prev link will hold the address of the previous node and the next link will hold the address of the next node. Here, in the case of double linked list, what is the benefit? That double linked list will, we can traverse in the both way, both direction at any time. But what is the problem for the single linked list? For a problem for a single linked list, if you are going to B, we cannot come back to A directly. That means one way direction is there. That was the problem. The traversing is in both way is not possible. So that is the problem that can be solved by using doubly linked list. All right. Now coming for the another data type for a doubly linked list, as you already know, there are one is called next. To define that, one integer type of data we have stored and two structure pointer we have declared one is next and another is pref. All right. Advantages over single linked list. W linked list can be traversed in both forward and backward which node the node very easily of double linked list. But in the case of single linked list, if the node which we have to delete is given, we cannot delete it very easily. We have to know the previous node address pointer. What are the disadvantages of double linked list over single linked list? Every node contains extra memory to hold the address of the previous node. That is the only disadvantage of double linked list. Okay, coming to the next slide. Another type of linked list we have to use, that is called circular linked list. Circular linked list means, as you already know, in a single coming back hold the address of null, address of any on. What was the problem for the single linked list? As you already know, if you are going forward, you cannot come back to the first node. So that was the problem. Here in the circular linked list, the last node will hold the address of the first node. There must be some circular path from the last to first. So that is the difference between single linked list and circular linked list. And another difference is we can easily traverse A from C directly or from B directly here in a circular way. So that is the benefit of the circular linked list. Now, list. Now, if we want to insert in, if we want to traverse a single linked list, how to traverse? To traverse the single linked list, we are coming to traverse the single linked list. First, starting from the first node, we have go to the up to the, as you already know, for a single linked list, the last node will hold the address null. So up to we are not reaching to the null, we have to traverse whole. So here we are giving the condition here. If header equals to null, printf list is empty. Otherwise, temp equals to header. Here we are giving the condition until temp not equals to null. We are printing the data and we are going forward. How to going forward? Temp equals to temp next. That means if temp is the current position, the temp next means what? That will the address of the next node. So for the next time, temp will go to the next node. So that is the temp equals to temp next. So in that way, we will traverse whole the list. Now going for insertion in a single linked list. So insertion can be done in three ways. Either we can insert a new node into the first position. We can also insert a new node at the last position. Also, we can insert a new node at any middle position. So how we can insert a new node at front? To insert that new node at front, as you already know, every linked list first node will be held by whom? The head pointer. First, we have to create the new node. After that, we have to connect that node with the head node. That means new node next equals to head. Now, after connecting that new node with the entire list, then what we are doing? We are taking the head pointer to the new node. Here we are writing now head node will point to new node. Here is the code you can see. To insert the new node, what new node next equals to head. and head equals to new node. So only that we can insert a new node at the front, coming for the insertion at the end. Now, as you already know, the last node will hold the address null. If we want to insert that new node at the last node will hold the address of the new node. So first we have to traverse to the last node. To traverse to the last node, here we cannot use the traversal algorithm directly because there is a condition here temp node equals to null you are giving. But here to traverse to the last node, we have to give the condition while temp next node equals to null. So while temp next not equals to null, what you are doing, temp equals to temp next. That means starting from temp here, for the next time, temp next, that is the temp next part, that is not null because temp next hold the address of that node. Now for the next time, temp is coming to here. Now after coming to here, for the next time, temp next not equals to null, temp will go to here. Now temp next is null. That means temp will go to the last node. After that, what you are doing, temp next equals to new node. This connection we are building. So if you are building that connection, automatically the new node will be inserted at the last. Okay. Now coming, here is the code. You can see to traverse to the last node, we are giving temp next not equals to null and temp equals to temp next. All right. After this one, what we are doing? Temp next equals to new node. Now insert at any position. To insert at any position, what we are doing? Now insert at any position. To insert a new node in between 20 and 40, what we are doing? First, new node next part will be connected with 40. After that, what we have to do? New that node 20 node, that if that node is the temp node, what we are doing? Temp next equals to new node. That we have to correct. Here we are using new node data, new node next equals to null. Okay. Insert at any position. Like here you can see new node next equals to temp next and temp next equals to new node. All right. Here we can insert a new node at the any middle position. Okay. For a double linked list, if you want to insert at any position, that will what we have to do. We have to here first new node next equals to temp next and new node prep equals to temp, and here temp next equals to new only, and temp next prep equals to new. You have to connect 4 pointer here. You can see 4 pointer exchange we have to do. For inserting a new node at the any middle position. You can see 4 pointer exchange we have to do for inserting a new node at the any middle position. Okay. Today I am completing that class up to here. Okay. Thank you.